Okay, when we turn to the back, now we're comparing Berkeley's and compared to Ivan. So first for Berkeley, you had to take 10 miles and times by 5,280 and write that in scientific notation. Should have been 5.28 times 10 to the fourth power. Then we compare Ivan to Berkeley. A lot of you put Berkeley on top, but the directions say comparing Ivan's wireless range to Berkeley. So it should have been Ivan over Berkeley. When we divide our decimals, we get 1/2. Now, check it out. 10 to the third power divided by 10 to the fourth power is 10 to the negative first power. The way we write that is 1 over 10. Then when we multiply across, 1/2 times 1/10 is 1/20. A lot of people put 20, and I maybe gave you 1 point on that. We had to have 1/20.
How's it going, drinkers? My name is
the
Game Drink,
2.
as you already know. So as of right now,
you had to basically look. Now, some people actually wrote out and moved their decimals and created a common unit. That was fine. Or you could have just looked at, okay, the smallest exponent here is the 6. Out of the exponents that are 6, if you compare the decimals, the smallest one was Pluto at 2.3. Okay, then would have been Mercury and then Mars. Then when we jump to Venus, out of the 7 exponents, Venus is the smallest, then Earth, then Neptune, then Uranus. And then Saturn was out of the 8 exponents, Saturn is the least, and then finally Jupiter was the biggest. Part B.
Okay, matter of fact, no, we're not going to go to YouTube because I remember last time I did that, I got a copyright strike and it cut out.
You got 0.622.
Not a strike, I didn't get a strike.
10 to the 8 divided by 10 to the 6 is 10 squared. We then move our
Shut your
decimal
mouth.
2 times to get 62.2. I did accept just 62 times. Last 3 problems were the most challenging.
Yes.
Almost everyone got the last 3 wrong. So if you did get them correct, excellent job because these were tough. First, we were told that the tank had 175 liters. Well, 1 liter is 1.0 times 10 to the negative 12. So you had to multiply those 2, and you should have gotten 1.75 times 10 to the negative 10. Montreal, make sure you're working in your seat at a 0. Thank you. Then we take that answer and we multiply it by our fun fact of what Pat's tank could hold. That's 7.43 times 10 to the 18th power. When we multiply our decimals, we get 13.0025 times 10 to the 8th. You can't keep it at 13. You have to move your decimal over 1. That means our exponent moves up. So we're at 1.30025 times 10 to the 9th power. Last part, letter C. All right, so you had to know, they said the tank holds an additional 75 liters. So the original was 175. You had to add 75 to that to get 250. How do we write 250 in scientific notation? 2.5 times. So, well, first of all, before we do that, we have to times it by, if it was 250 liters, times that 1.0 times 10 to the negative 12.
No.
And that gives us 250 times 10 to the negative 12, which is then 2.5 times 10 to the negative 10. We then set up a ratio comparing the Atlantic Ocean compared to the tank. Atlantic Ocean, written in scientific notation, was 3.236 times 10 to the 8th.
Go away, sir.
And then we set that up over the tank's amount, which was 2.5 times 10 to the negative 10. When we divide our decimals, we get 1.2944. 8 minus a negative 10 is really like adding a 10. So we would have 10 to the 18th power. Okay, so overall in this group, really good. A lot of 80s and 90s in this front group, so excellent job. If you got an 85% or higher, please give your test back to me so I can figure it out with your class under my math. All right, now what I'd like you to do is keep your eyes up here. I want to go over exit ticket from yesterday. So what you were given, and the answer's already up here, but if you take a look, yes.
Slice your fucking nose off.
Okay, well. Or you were checking your, remember?
Oh, do it.
All right, so translate point Z along vector AB. So first, on the chart is now right up here above Tierra. For when we're translating, remember, translating means we're sliding.
There we go.
So first step is to trace everything. So I trace, I have A and B here with my vector pointing down, and then I have point Z. A lot of people forgot to trace point Z. Then I need to look which way my vector is pointing. It's pointing down, so I'm going to move down. How do I know when to stop? When I get to the end of the vector. So I slide down, And now I'm going to retrace. Now, a lot of people did this. A lot of people traced the vector down. Why is that wrong? Because the directions say, what are we actually translating? We're translating point Z. That's the thing you're supposed to mark. We don't mark our vector. We mark whatever translate means we're sliding that point. So that's what we had to mark.
I missed my part because of you.
And then it tells us to connect Z to its image Z1. So I make a line connecting those two. Now it asks me what's true about these two lines, and then you should have said that the two lines are parallel. What's true about the lengths? They are equal. Okay, so a lot of people, we don't extend out the vector. That's not what we're asked to do here. The thing that you re-put on your paper, step number 4, when you transfer to your paper, it's whatever they asked you in the directions to translate. Okay, this time, please get out your life's work, and I'm coming around to check number 1. I want to see what everyone did for number 1 on the life's work last night. Okay.
Oh, no.
Where?
You said Mr. Johnson asked for you to? All right, I'm just going to come around to take a look at number 1. So please have that out on your desk. You do number 1. Take a look what number 1 is. What about the last? I have somebody out right now. Okay, good. So some of you sort of did it correct, some of you didn't. So I know some people got a little confused. Number 1 was actually the part with the graph. That's what you had to do there. So let's take a look here. We're going to redo it. If you already did it, you can be double checking your work. So the directions say to translate X, Y, Z, which was our angle, to translate point A, point B, and the rectangle. So first thing, what is my first step I have to do with everything? If you don't know, it's on our chart right up there. Samari, those steps you need to write down in your notebook. Okay. So what is the first step? Samari, you can just tell us, what do we do? Good. So we have a measure here that's X, Y, Z. What else? How did I know to trace that? Because the directions told me. I'm translating the measure of X, Y, Z. What else do I have to trace? Hello? Hello? Point A. Good. Here's point A. What else do I have to trace? Point B. We're looking in the directions. What else do I have to trace? Good. The rectangle HIJK. And I don't mean just kidding. Okay. Now, what is my second step? What do I have to do next? Say it.
Look which way.
Now, this was kind of hard to see, but the vector was on EF. How did I know? Because I see an arrow here from E to F. That was my vector. So I have E and F. And now, which way is my vector pointing? Hello? Which way is my vector pointing? Up to the left. So that means I'm going to be moving that way. Okay, so now step 3, I'm going to actually move. We're not eating in class. Put that up. Thank you. Now we're going to be moving along the vector. So I slide up, I stop at the end of the arrow, okay? And now you should have retraced, because that's step number 4, transfer all of these things on your paper. So I should have had a measurement here that was transferred over. That new measurement becomes X1, Y1, and Z1. Okay, I also have a new point. Point B is now B1. I have point A, which now becomes A1. And then I have my new rectangle, which was moved over. And now, does it matter where I put the H-I-J-K on here? Yes, it does matter. They have to be corresponding with the exact ones. So this point right here would be what? H1.
Cheeseburger and a bun.
This point would be I1. This point would be J1. I'm only hearing 2 people participate. And this point would be K1. Now I have 4 people. Thank you. Okay, so when we're translating, that means we have to look at what is it telling us to translate. That's what we're moving. Okay, and then we're sliding. Remember, when you translate, it means you're sliding. Okay? So, let's review. The first type of transformation we learned about was a translation.
Wait, I got pants on.
The way I remember, translation is a slide. Right? Translation, slide. Okay, makes sense. They both have the SL. Okay? Transformations are the entire, what these 3 types of movements are. We have translation, and now today we're going to be learning about a reflection. When you hear the word reflection, you might think about like a mirror. We're going to be reflecting images across a line. And here's what it means. Reflection, flip. Reflection, flip. So they both have that FL. So what I'd like you to do is track up front. And I'm going to be showing you, I'm modeling for you what this looks like when we're doing a reflection. So eyes up here, nothing in your hands. This is just the time to learn. So eyes up front. Thank you, Shemaya, following my direction. Thank you, Jamarian. Thank you, Tierra. Thank you. I'm gonna line it people as soon as it's your crowd. Okay. And let's say I have points
I'm just gonna
P.
It's no reason
Q,
for me to go on any longer. Just
and
and drink.